This example for kinematics involves curling, a popular winter sport in some areas. A stone is slid across the ice towards a target at the far end, sometimes knocking other stones out of its path. It's kind of similar to shuffleboard, and it takes quite a great deal of skill, actually. In this example, a curling stone glides on ice a distance of 39.2 meters for 14.3 seconds before stopping on its own. So I'm underlining kind of the important words in the sentence that will help us determine what the stone does. I'm going to start with a velocity time graph. It doesn't need to be very big or super detailed. I know the stone has some initial velocity. I know it's going to come to a stop, so it slants downwards down to a stop down here. I know the time it takes to stop is 14.3 seconds. And the distance traveled is 39.2 meters. Making the list of variables, the initial, A, T, and delta X. I know that the final velocity of the stone is 0 meters per second because it stops. V initial is what I want to know for part A. Acceleration is what I want to know for part B. Time is 14.3 seconds, and delta X, it says up here, distance of 39.2. So that would be the delta X. To begin part A, I need to decide which equation to use. So here are the kinematics equations that we've used in the past. I'm looking for V initial, and so I need to find an equation that has V initial. This is a fine equation, except that I don't know the acceleration yet. Solving for V initial, this would be a fine equation, except I don't know the acceleration yet. This would be a fine equation. I don't need to know the acceleration. It's missing out of the equation. That might be good. Again, this equation involves acceleration. I don't know that yet. That's part B, so not a good choice. It looks like equation 3. Delta X equals 1/2 V plus V naught times time. So for part A, V equals, I lied, delta X equals 1/2 V plus V initial times time. I could solve it. I have a couple different choices. I can solve it using algebra. I can go ahead and just put the numbers in right now. I think I'll solve it using the numbers first. So 39.2 meters equals 1/2 of V, 0 meters per second, plus V initial, which I don't know yet. There's my parentheses. This parentheses doesn't belong. Times the time of 14.3 seconds. My 0 goes away because 0 doesn't add anything to my overall solution. 39.2 meters equals 1/2 V initial and 14.3 seconds. All multiplication, all division, all multiplication. So when I solve this, I'm going to go ahead and not need to use any addition or subtraction. My first step would be to multiply both sides by 2, because that will get rid of my fraction of 1/2. I'm going to now divide by 14.3 seconds. Again, because that now will cancel out that, and I will be left with V initial right here equaling whatever that number reduces down to. So on my calculator, 2 times 39.2 divided by 14.3, I get 5.48 meters per second. 5.48 meters per second. And there's my answer to part A. I can go ahead, I'll just 5.48 meters per second. I'll just write that in there just to kind of help a little bit. For part B, I need to find acceleration. At this point, now because I know the initial velocity, really I can pick any of the equations I want that have acceleration in them. Okay, so this would be a good choice. I know the velocities, I know the time. This would be a good choice. I know distance, I know velocities, I know time. This is not a good choice because it doesn't have acceleration in it, so I can't solve for acceleration. This is a fine choice. I know velocities, I know distance, I could find acceleration. I think I'll use, it just doesn't matter too much, I think I'll use the last equation. V squared equals V initial squared. You could, if you were solving this on your own, you could have picked one of the other equations and solved it for acceleration yourself, and we should all get the same answer. I noticed looking that V final is still equal to 0, so I have 0 equals V initial squared plus 2A delta x. I'm going to solve algebra first this time. So my first step, before I put numbers in, my first step would be to subtract V initial squared from both sides. So I would have V initial squared, negative V initial squared equals 2 times A times delta x. I'm solving for acceleration, so I want to divide by 2 and delta x. I want to divide by 2 and delta x. I like to put the little multiplication dot in there just to help remind that delta x is really one thing, not multiple things. So the 2 and the delta x will cancel out. Finally, my equation will look like V initial squared over 2 times delta x. A negative sign in front because if the stone is going one direction forward and it's slowing down, acceleration must be acting in contradiction to that and therefore be negative. Plugging in numbers, I will get A equals negative V initial, I was told from, I found out from part A, is 5.48 meters per second. That whole thing is squared over 2 times delta x, I was told is 39.2 meters. On my calculator, 5.48 divided by 2 and divided by 39.2 gives me 0.0699. So acceleration equals negative 0.0699. Now the units, I have here on top meters squared over second squared. I'm canceling out one of the meters, so meters per second squared, which is the expected unit for acceleration, and so that worked out fine and everybody's happy.